All right. Hi, everyone. We are back again with Math Monthly. It is April now. Can you believe it? This will be our last Math Monthly of this semester, but we'll be back in the fall. This month we are going to look at looking for and making use of structure. So structure can show up in a lot of ways. It can show up in patterns. It can show up in numbers. It can show up in formulas or algorithms. And in fact, pattern, formula, and algorithm are our three vocabulary words for this month as kind of different ways of looking at structure. What's great about those things and about structure is that if we can teach students to recognize those things and use those critical thinking skills that we talked about last month, they can see that these are tools to be able to recognize those structures in later, more complicated problems and apply the same thinking and to really be able to visualize and recognize that and to see how it can be helpful as they get into more advanced material. So, with your little guys, patterns are so huge, and there's patterns in the world all around us. That's what's fantastic, is they are readily available in your home, in nature. It can be colors, it could be shapes, it could be textures, it could be numbers. You can really encourage almost anywhere you are for your students to be looking for patterns all around them. You can have them identify patterns, you can have them arrange things in patterns, and just really get those little eyeballs turned on to looking for that everywhere in their world. And when they get a little older, they'll start to learn formulas for things, right? And formulas are just based on patterns. Mathematicians discovered formulas by going through and noticing what was always true. If you think about the formula for the area of a rectangle, for instance, just length times width, that formula was developed because when you have a rectangle, it is always the length times the width to give you the total number of square units. So formulas come out of patterns. And I think if you can approach them that way with your students, instead of just a formula that's kind of come out of nowhere to be memorized, it makes so much more sense. When possible, if you can let them discover those formulas, that is really, really powerful to their mathematical understanding. And it makes it so much more fun for them to feel like they have actually contributed to making a discovery. They have found it, and it's going to stick so much better for them that way. Then we all know about algorithms. This is so much of what we traditionally learned growing up. Long division is probably the most common one. You write the division bar, and then you write down and then up, and there's that set of steps that you repeat over and over and over and over. That's what an algorithm is. And algorithms are great. Again, they're just patterns. They're just capturing a pattern of thinking and giving us a structure in a way to write it. So algorithms should really be the last thing you're teaching your students. Again, whenever you can allow them to discover something on their own, or to think through in their flexible thinking. Kids are so powerful. Their minds are so powerful. They don't know all that we know, and they haven't necessarily been bogged down by that. So they can come up with really creative ways of solving problems. And an algorithm can be introduced at the end as almost like a shortcut. Here's all these things you were already doing, and I'm capturing your thinking in writing or in a structure. But all it should be doing is capturing the thinking that was already happened. If you teach the algorithm first, like so many of us learned, they lose the opportunity to really deeply understand why they're doing the steps that they're doing in the algorithm. So kind of, my big tip with this is to just look for those patterns and structures as they come up and do things to highlight them as much as possible with your students. Color coding is a really powerful way of doing that. Helping them to see multiple representations. For an example, an equation can be represented as an equation. You can look at the graph of the equation, or you can look at a table of values that are part of that equation. And so being able to see that all those different representations mean the same thing, color coding can be really helpful in that to help them see what's connected to what. So I just thought it'd be fun to do a little number talk, or actually this is a pattern talk, as a way to just get us used to using patterns to help us solve problems. So there is a link on here. This is a lesson plan from ucubed.org, and I've adapted it, but it's just using this little image that I have up here and asking your family to just kind of take a quick peek at it, put it up for just a couple of seconds, and ask them to figure out how many of each shape they see without counting. And what's great is when you have that conversation with them, I've included some questions that you can ask and some things that you can think about. And you'll see that everybody sees it a little bit differently. Everybody captured a different shape in the calculators, or they noticed a different pattern amongst the rulers. And again, on that lesson plan on YouCubed, they have a bunch of dot patterns that you can use to expand on this. You can do this with numbers, and just get in the practice of asking those questions. It will help your students start to develop their recognition of patterns, and then as they recognize those, to be able to, again, apply them as they get into more and more complex math. All right, well, have a great rest of this school year, and keep enjoying math.